Hi guys, so here we meet again with the collision lab. This is the lab following the energy lab that we did last week. So like last time, I made a little document for you to help understand the theory and all required for this lab, which is different from the lab manual given to you. Okay. So momentum is given, impulse, the definitions are given, so I'm not going to spend too much time over here, and I'm going to directly take you to the link that we are using this time. So you can find this link in the physicsclassroom.com, and if the clicking doesn't work, you can actually do a cut and paste and choose a web browser and paste it over there. Yeah, cut and paste it over here. Okay, and then when you go to the page, you will find this animation box, and in order to make it bigger, you can click on this icon here, and then you can choose the elastic collision for the first part of the lab, and then you can change the masses and the initial velocities, right? So the masses you can change like this, and the initial well, like this for the blue card, and then the initial velocities can be changed by using these arrows to increase or to decrease. Okay, and then the first time we are keeping the initial velocity of the blue card as 0, so you can actually bring it to the middle. I don't think it is given in the instruction, but you just can play around and find the best position for each car, and once it is set, you can use the run button to start the animation, and you can note down the initial velocities of the two cars and the final velocities of the two cars after the collision, and then you can go to the tables. They are down here. So the red card before collision, the mass and the speed given, after collision mass, speed given. So the momentum equations are given, and you can find the momentum for the red card, for the blue card, and find the change in momentum. All right, and then you can go back to the animation, and you can choose the inelastic collision, and when you are choosing the inelastic collision, you are making the red card velocity little bigger than the blue card velocity, and in that case, in that case we make sure that the blue card is in the middle of the track, and the masses, again you can change the masses to whatever the values that you prefer to use here, and then I'm using 2 and 1. How about that? And then I start the animation, and this is a perfect inelastic collision. You can see after the collision the cards actually stick together and move. So that's the lab for this time, and there are 2 tables. This is for the second experiment that we just did. So you can just fill this table by taking down the mass values and the velocity values before and after. And also please go over the procedure and data collection section, because some of the discussions that I would like you to do, they are inserted here. For an example, the last part of part 1, or the first experiment, here it says find the kinetic energy of the system before and after. Discuss your observations. What can you say about the 2 energy values? So when I ask you to find the 2 energy values separately for the system, you find the kinetic energy of the red card, kinetic energy of the blue card, and then you add them together. That would be the initial kinetic energy value, and do the same for the energy values after the collision. So this is going to be an easy experiment, and if you have any questions, please make sure to contact your TA, or you can directly contact me. I'm Dr. Mohotala at the University of Hartford. All right guys, good luck.